right. So we get started. All right. I want you guys to start by finding all the real solutions to this equation. Example 1 on your packet. Now, I've given you a hint. We're using the completing the square method to solve this. Who remembers how to complete the square? Does anybody ever remember hearing the phrase, completing the square?
Hold on for this. I don't think it's fair, though.
Anybody have an idea as to where it started? Okay. Are either one of these easily factorable? Okay. Let's do this together. All right, completing the square. Kind of a, I'll give you a better description tomorrow. Right now, I want you to kind of pay attention as to how to do this, okay? So what we're going to do is we're going to solve that one to be equal to 0 and this one to be equal to 0. Because if either one of these are 0, then the whole thing is 0, right? So let's start with, and I want to do these in different colors. Let's do this one in red here. Okay? So I'm going to say x squared minus 6x plus 3. I'm going to set that equal to 0. Now the first thing I would try and do is I'll try and factor this thing. I want to find two binomials that multiply with each other to make this. Well, I know x squared factors into x times x, and I know 3 is 3 times 1. And there's no other way to write it. Now, because this 6 is negative, I know both the 3 and the 1 have to be negative. Right? Because they have to multiply to be 3, but they have to add to something that equals negative 6. And when I look at this, does this equal this? 3x, or I'm sorry, negative 3x minus x gives me negative 4x. So this, I can't factor this expression. So I need to come up with a different solution. And one of the solutions that I've come up with is called completing the square. And this is funky. So here's what I want us to do. First thing we're going to do is we want to make this coefficient in front of my x squared, we want that to be equal to 1. It's already 1 here, so I don't have to worry about it. When I do this one, though, I'll have to make that coefficient 1, and we'll show you how to do that in a second. So, my coefficient in front of my x squared term is 1, so I'm happy with that. Second thing I want to do, I want to get this 3 over here. Okay? So I just subtracted 3 from both sides. Okay? Now, here's what you're going to do. Everybody see this negative 6 right here? You want to take half of that negative 6 and square it. So what's half of negative 6? No, not negative 6x. Just the number. What's half of negative 6? And then square it. Okay, hold on. What's half of negative 6 again?
Nothing.
Half of negative 6 is not either positive or negative 3. It's always negative 3, right? Half of negative 6. Negative 6 divided by 2 is negative 3, right? Always, always, always. So now I got that half of negative 6 is negative 3, and I square it, and I get positive 9. All right? I'm adding 9 to both sides of this equation. So now I got x squared minus 6x, I'll do this in green, plus 9 equals negative 3 plus 9. So I've added 9 to both sides. Okay? So how did I find this 9? Half of my coefficient in front of the x. So half of my x term, don't forget the negative sign, and then square it. Okay? So now, half of the middle term, and then square it. Now, here's what I got. I got x squared minus 6x plus 9 equals negative 3 plus 9 is positive 6, right? Now, this is something I can factor. I can factor this. Not only can I factor it, but I can factor it into a perfect square polynomial. This is going to be x minus 3 quantity squared. Now, how does this help me in solving x, solving for x? What can I do at this point? If I take the square root of both sides, then I get x minus 3 equals plus or minus the square root of 6, do I not? And then x, I solve for x by adding 3 to both sides. So I got x equals 3 plus or minus the square root of 6. Okay, so here's what I want you to consider. These are the steps for completing the square. One, the square. And I'm going to use the generic quadratic equation, ax squared plus bx plus c equals 0. Okay? Actually, I don't want that equal 0. Well, yeah, we'll do equal 0. So, here's the first step. 1. Ensure that a equals 1. So that number in front of x squared, I want that to equal 1. Okay? Once I have that, then I move on to step 2. Step 2 is subtract both sides, or subtract c from both sides. Step 3. take half of B and square it. Adding it to both sides. Step 4, factor and solve. Okay, those are your 4 steps. Those are your 4 steps. So first, I'm going to ensure that my coefficient in front of my x squared is equal to 1. And I will show you on the next one how to do that when it's not 1. Then I'm going to subtract c from both sides. I'm going to take half of my b value and square it. And lastly, I'm going to factor and solve for x. Okay? I'm going to go back. We're going to apply these 4 steps to the second of our 2 quadratics. You want to go back? All right, I will give you a minute to finish copying. Are we ready? All right. So now I want to do this one over here. The 2x squared minus 4x minus 7. I want to solve for that. So now I'm going to do 2x squared minus 4x minus 7 equals 0. I'm going to solve for that guy. So, is my A term 1? So, here's what I'm going to do to make it 1. Is I'm going to factor out a 2 from this polynomial. So I got 2 times something equals 0. If I factor a 2 out of this term, what am I left with? X squared, right? And if I factor a 2 out of this term, what am I left with? Minus 2x. And then out of this term, 3.5. Screw that. 7 halves. 7 halves. What's that? So, now, how do I get rid of the 2? Divide both sides by 2. Not by c. 2. And divide by 2. On this side, my 2's go away. And what's 0 divided by 2? 0. So I've gotten rid of my 2's, right? So x squared minus 2x minus 7 halves equals 0. Now, I want to get rid of this guy, right? I want to move c over to the other side. So I have to add 7 halves to both sides. So now I get x squared minus 2x equals 7 halves. Now here's the magic step. What's half of negative 2? Squared. So I'm adding 1 to both sides. So I got x squared minus 2x. I'll leave a gap. 7 halves. plus 1 and plus 1, right? You falling behind again, Andrew? All right. How about the people in back? Can you see? Am I going too fast? Okay. No, thank you for the feedback. I need that. Otherwise, I'm just off to the races. All right. Are we caught up? All right. Now, this guy right here, half of the middle term. What? No. Negative 1. Squared. Squared is plus 1. All right. So how does this guy factor? It's going to be a squared term. It's going to be x minus 1 quantity squared equals 7 halves plus 1 is 9 halves. Seven halves plus 2 halves. 7 plus 2 is 9. 7 halves plus 1. How many halves are in 1? So 7 halves plus 2 halves. 9 halves, right? Now, square root both sides, right? I got something called x minus 1, all squared equals 9 halves. So square root both sides, you get x minus 1 equals what's the square root of 9? Plus minus 3 over square root of 2. Rationalize. I get plus or minus 3 root 2 over 2. So x minus 1 equals plus or minus 3 root 2 over 2. And then to solve for x, I simply add 1 to both sides. So x equals 1, and actually, yeah, I'll do it that way. 1 plus or minus 3 root 2 over 2. Can I put that under one fraction? I feel like I'm going too fast again. It is a lot of work. It is a lot of work. This is going to help me to sell the next exercise. Three root 2 over 2. Did you lose me right here, Lou? No. Look, is this where you lost me? Okay, what's the square root of this? It's just this, right? What's the square root of this? Square root of 9? Square root of 2? And then I just rationalize, right? I multiply both the top and the bottom by square root 2, and I get 3 root 2 over 2. That's how I got that. Adding 1 to both sides. So now I got 1 plus or minus 3 root 2 over 2. Now check this out. Those are the values of x that when I plug it into this equation, it will equal 0. Not only that, those are the only values of x that will do that. Now, again, a red one and a blue one, there is another way. Because who likes the first way? Josh likes it. Jasmine likes it. Caleb likes it. But here's the second way. Who remembers this?
Oh, yeah. Oh, yeah.
Completing the square or the quadratic formula? So, there is a song apparently. So I can plug in, what's my A value here? 1. What's my B value? Negative 2. And my C value? -4. I plug it into all the appropriate places on my quadratic formula, and voila, I get the values of x that make this red equation equal to 0. Okay? I do the same thing for the blue. And then I find the 4 solutions for x that make this thing equal to 0. Okay? So let's practice with the red one. Everybody plug in their appropriate numbers into the quadratic formula and see what you get. I don't want a decimal number. I want it in a similar form as we had here and here. I want a number plus or minus a radical term. If we can simplify it from there, then so be it, but I don't want to, if you get like a square root of 2, I don't want you to simplify that or make that a decimal. So let's crack on that. Use the quadratic formula, you two. Don't touch yourself. No. Yep, we're doing this one. And we're doing the one on the left. And we're using the quadratic formula. Yeah, those are. Those are That teacher's looking for a screen when you do that. It's the factor of the house, it's the factor of the house. Is that a factor of the here? All math teachers that are purgatory cry when you do that. They get like 30 lashes. What's up? What's the matter? Well, let's say, whatever comes to what a root's like, that's a positive and negative square root. Well, you got two times the square root of that. It's not times plus or minus. You can't do plus or minus. Plus it. You can minus it. You have two separate equations. But instead of doing this, watch here. So, what do we got for B? B is negative 2, right? So I get the opposite of negative 2. Plus or minus the square root of negative 2 squared minus 4 times 1. Listen up! Times C, which is negative 4. All over 2 times 1. And now all I do is simplify. So, the opposite of negative 2 is positive 2. Plus or minus negative 2 squared. 4. 4 times 4 is 16. Positive. Okay, just be able to simplify from here.